Alright, let's look at the fundamental theorem of calculus part 2. Alright, let's say function is continuous on a closed interval from a to b. Alright, integral from a to b of f of x dx can be found by capital F of b minus capital F of a, where capital F of x is just any antiderivative of lowercase f of x. So f prime of x is exactly equal to f of x. Alright, let's first try to prove this theorem. Alright, so first we're going to let g of x is equal to integral from a to x f of t dt. Right? So from using the fundamental theorem of calculus part 1, so fundamental theorem of calculus part 1, we know that g prime of x is simply f of x. Right? And which tells us that g of x is going to be an antiderivative. So this is going to be antiderivative, which is capital F of x. And they might differ by a constant, so we're going to put plus constant c. Alright, so let's use that to prove this. So start out with the left-hand side, which is the integral from a to b f of x dx. Alright, and this is going to be equal to g of b minus g of a. Alright, g of b actually gives you exactly the same thing, because if you plug in b for x, we have an integral from a to b and f of t dt, which is same thing as f of x dx. Right, minus g of x, we're going to put that, but g of a. If you plug in a here, this is an integral from a to a. It's 0 anyway, so we're subtracting 0. So this guy is actually just a 0. All right? But since we know that g of x is an antiderivative, so we can write it as, all right, g of b would be capital F of b plus some constant c minus, and g of a would be capital F of a plus some constant c. All right. So we can cancel capital C minus capital C there, right? So what you get is capital F of B minus capital F of A, all right? And that is the fundamental theorem of calculus, part 2. All right, so let's use the fundamental theorem of calculus, part 2, to evaluate the following definite integrals. Right? So let's look at the number 19. Right? So first thing we have to do is find the antiderivative. So I'm gonna go here. Right? So I usually put the square bracket here. Right? Antiderivative x cubed is add 1 to the power, so 4. Divide by that power, so 4. Just the power rule. And antiderivative of negative 2x would be negative x squared. Right? Then you're going from negative 1 to 2. Right? Then what we want to do is we're going to plug in the top number first, the upper limit first. So plug in 2 to the 4th power over 4 minus 2 squared, right? Then minus, plug in the bottom number, So I'll plug in, let's see, I'm going to plug in -1. So you have a -1 to the 4th over 4 minus -1 squared. All right, so let's simplify. So you have 2 to the 4th is 16. Divided by 4 would be 4. So this would be just 4. And 2 squared with 4 too. So you can see that the 4 minus 4 cancel out. So they are gone. All right, so what you get is just going to be, all right, so this is a negative sign. So -1 to the 4th is going to be just 1. So 1/4. So you have a -1/4. All right, then you have a negative. So it's a plus. -1 squared would be 1. So it's 1 minus 1/4 is 3/4. All right, so this is the value of the definite integral here. All right, so let's look at the next one. All right, so we just do it the same way. So we find the antiderivative of secant square of t, which would be tangent of t. So we have a tangent of t. Then you're going from 0 to pi over 4. All right, so first thing you do is plug in the top number first. So upper limit first. So you have a tangent of pi over 4 minus and tangent of 0. Right? And the tangent of pi over 4 is 1. And the tangent of 0 is actually 0. So this is going to be just 1 minus 0, which is 1. All right? That's it. I hope that this was clear.